Hello everyone, welcome to the lecture series on foundation engineering. In this video, we are going to see about different bearing capacity terminologies. In the previous video, we have seen that any structure can be divided into two components. One is the substructure, another one is the superstructure. Here, I am drawing a sample footing which is located at a depth of df below the ground surface. So this is our ground surface, where the load from the structure is acting upon it. You can see that this is the bottommost layer of the soil on which the foundation is resting on, right? In addition to the load from the structure, some other thing is also acting upon the bottommost layer. That is the soil which is surrounding the foundation, right? If I'm considering this as my layer, whatever the soil that is above that layer is also acting some pressure on it, right? So which is acting in the downward direction. So which is Q of soil. In addition to the load from the structure and the load from the soil, you can see that the footing or foundation itself is exerting some pressure on the soil. So this I am mentioning as Q of foundation. So I can say that the total gross load acting on the bottommost layer of the soil on which the foundation is resting on is equal to Q of structure plus Q of soil plus Q of foundation, right? But think once, is the soil new to this place? The soil has already been present. Only the new thing here are the load from the structure and the load from the foundation, because that is what we have constructed, right? So the net load is nothing but the load from the structure and the load from the foundation. I believe now you can understand the difference between the gross load and the net load. Gross load means the one which is a combination of the load from the structure, the load from the soil, and the load from the foundation. Whereas net load is nothing but the additional load that is imposed on the soil. That is the load from the structure and the foundation alone. Understood? Now, I believe you know the difference between load and the pressure. Say, for example, for this foundation, I'm drawing a plan view where the length is L and the width is B. Or rather, I will have this as the length and the breadth. What is the area? It is nothing but L into B. So I can say the intensity of loading or the pressure is nothing but the load divided by area. So if I'm saying intensity of load, then it means it is pressure. What will be the unit? Usually it will be in kilonewton per meter squared or otherwise kilopascal. What will be the unit of this load? It will be kilonewton. And what will be the unit of this area? Usually meter squared, right? So you should always know the difference between load and intensity of loading or pressure. Now let us go and see the various bearing capacity terminologies one by one. Gross and net. As I have told you, if it is gross, then it means you have included the weight of the superstructure, the weight of the soil, and the self weight of the footing that is acting upon the bottom of the foundation, which is lying at a depth of df below the ground surface. I'll draw this again here. If this is our foundation, which is acting, which is located at a depth of df below the ground surface, at this particular point, gross pressure is nothing but the sum of all the weight from the superstructure, footing, and the soil itself divided by the area of the footing. So that will give you gross pressure and gross or the gross intensity of loading. That is Qg or simply Q. The next is net pressure. What is this net pressure? Net pressure is nothing but the pressure, but excluding the pressure from the soil. So if we have written it in terms of load, it will be Q net is nothing but Q soil, Q structure plus Q of foundation, right? Now, what I have done here means Q net can be written like Q gross. Remember, Q gross includes the pressure from the soil also. So what I'm doing, I am subtracting the effect of the soil, that is the pressure exerted by the soil. You might have studied this in your soil mechanics in the concept of stress distribution, where the stress exerted by the soil at a particular depth is nothing but gamma into df. So I am subtracting the effect of the pressure exerted by the soil. So Q net can be written as Q gross minus gamma into depth of the foundation. Understood? Let us move upon to the concept of ultimate and net ultimate bearing capacities. What is this ultimate bearing capacity or gross ultimate bearing capacity? Remember, the gross word will not be used all the time. So if it is simply ultimate bearing capacity, that means it is gross ultimate bearing capacity. What is this gross ultimate bearing capacity? Just now we have seen the difference between gross intensity of loading and net intensity of loading. So gross ultimate bearing capacity means the maximum gross intensity of loading, which means the intensity of loading from the effect of foundation, soil on the structure. The maximum gross intensity of loading the soil can support, that is this layer of soil can support before it fails because of shear. We might have seen that the two cases of failure are settlement and shear. So the maximum gross loading, the gross intensity of loading the soil can support before it fails by shear is called ultimate bearing capacity or gross ultimate bearing capacity. Now, what is net ultimate? More or less the same concept, but we are ignoring the effect of soil, that is the pressure exerted by the soil. So the maximum net intensity of loading at the base of foundation that the soil can support before it failed by shear, which means I am ignoring the effect created by the soil here because it has already been present there, right? So how much additional intensity of loading that I can keep on this particular layer of soil? Maximum. That is why I am using the terms ultimate here, because soon we are going to see the term called safe bearing capacity. So ultimate means, remember, the maximum that can apply on it, which means, say for example, I am having a table here. I can say the table can support a load up to 100 kg. Even if I add 1 kg in excess, the table will get damaged, right? So 100 kg is the maximum mass that it can support. So the maximum term, if it comes, it refers to ultimate bearing capacities. Understood? Now we are going to learn about safe bearing capacity concepts. Let us reconsider the example which we have seen in our previous slide. There is a table on which the maximum mass that I can keep is 100 kg. Do you think that I will take the risk of keeping all the 100 kg on it? Because even if it is exceeding 100 kg a bit, maybe 100.1 kg, is sufficient enough to damage the table. Say for example, this table is a very costly table which I don't want to get damaged, right? So what I will do, I will always restrict myself to 50 kg or 75 kg. I'll ensure that it is not going anywhere near this 100 kg. Yes or no? Because I want this to be safe. Likewise, to ensure my foundation is safe, I'm not going to load it to the maximum. Rather, I will restrict the load that is being applied on it and ensure that it is safe both in terms of gross and net scenarios. So for example, after doing all the calculations, I found out that the load that the foundation can withstand is 1000 kilonewton. Do you think I will apply all the 1000 kilonewton on it? No, I will restrict myself to say, for example, 500 kilonewton or 750 kilonewton, like this. So we are now seeing a concept called factor of safety. What is the factor of safety? You will reduce the maximum load that can be applied on the structure. When it comes to intensity, you will be reducing the maximum intensity that will be applied on a soil at its bottom. For example, instead of keeping it to be 1000 kilonewton, I am having a factor of safety 2. So now it will become 500 kilonewton, right? Likewise, instead of keeping it to be 1000, I am reducing it by 4 times. So my factor of safety is 4. This will become 250 kilonewton, which means I will restrict myself to 250 kilonewton, or I will restrict to 500 kilonewton if the factor of safety is 2. So I believe now you understood the concept of factor of safety. Let's move on to the safe bearing capacity terminologies. First one is net safe bearing capacity. See, the previously we had the term maximum, which means the maximum that you can apply. Here safe means whatever that you can apply, ensuring that your foundation will not fail by shear. Net safe bearing capacity. Net, if it comes, remember, we will always ignore the effect of soil pressure. Already we have seen that net ultimate is nothing but ultimate minus gamma into df. Here you have already ignored the effect of soil pressure. So I can say net safe is nothing but net ultimate divided by factor of safety as it is given here. So usually you will adopt a factor of safety of 2.5 to 3 while designing a shallow foundation. Finally, gross safe bearing capacity. What is this gross safe bearing capacity? This net safe bearing capacity is here, which have the ignorance of the effect by the soil pressure. Now what is gross? As I told you, gross means you will be including the effect of soil. So QS or QGS, if you want, you can use that. But my conventional terminology is to use simply S. As I have told you, it is not always necessary to mention it as gross ultimate bearing capacity. Just ultimate bearing capacity is sufficient, right? So instead of just mentioning it as QGS, I'm going to use as QS. QS is nothing but net safe plus gamma times DF. You may wonder why I didn't do like Q safe is equal to QU divided by factor of safety. I hope you have this question. Let us see the reason. Let us assume that this is empty ground in which I wanted to do a construction. I am excavating this to lay my foundation. Now I have laid my foundation. I am refilling the soil back. This is the ground surface, right? So I am refilling the soil back. At least most of it, since some part of the soil cannot be filled because I have laid my foundation here, right? Since I have laid my foundation here, I cannot fill some part of the soil, but most of it has been refilled. So we have learned that net ultimate is nothing but ultimate minus gamma df, that is the pressure exerted by the soil at the base of the foundation level, at this level, right? From which we have calculated the safe bearing capacity. I'm sorry, net safe bearing capacity, which is net ultimate divided by factor of safety. Based on some calculations, I found out that the maximum load from the structure can be, say, for example, 3000 kilonewton. Let us not go deep into this discussion. Assume that the maximum load from the structure can be 3000 kilonewton. As we have discussed earlier, we are not going to impose all the 3000 kilonewton. Rather, we are going to restrict it with the factor of safety. Say, for example, in this case, I'm going to take 3 as my factor of safety. So the safe load can be 3000 by 3, which is 1000 kilonewton. And I have a liberty to reduce the pressure from the foundation base. How I can do that? Say, for example, there is a foundation. Let us say the self weight of the foundation is 1000 kilonewton. L into P. It has a length of L and a width of B. Right. If the pressure exerted by the foundation is very high, I can increase the area so that I can redistribute the effect of foundation. So I have a control on the pressure from the foundation as well. Do I have the same liberty on the effect of soil pressure? The soil pressure is nothing but gamma into dF. We have excavated the soil, we are refilling it up to the same depth. So I don't have the choice of changing the depth of the foundation after all this construction. Do you think I can apply a factor of safety to the unit weight of the soil because I have excavated some soil and I am refilling it inside? In case if I am refilling it with an entirely different soil, slightly the unit weight will change. Maybe it is from 0.5 to 1 kilonewton per meter cube. The unit weight may change, but yes, the effect of 3 times the factor of safety, right? Or the effect which I have adjusted by increasing the length and breadth of the foundation. So factor of safety can be applied to the load from the structure and the self weight of the foundation. It cannot be applied to the pressure exerted by the soil at the base level of the footing. So what I can say is the factor of safety applies only to the structural component that has been added as extra, from which it is very clear the safe or gross safe bearing capacity is nothing but net safe bearing capacity plus gamma dF. You may wonder how this comes, because if I talking about gross, as I told you, I am not including the term G every time, but it is still understood as it is gross safe bearing capacity only. So if gross is there, I should include the effect of soil, but still it is safe, right? So factor of safety should be applied. That is why I have taken this term here. If I write it other way, Q Nu divided by factor of safety plus gamma dF. That is, I have taken the effect of load from the foundation and the load from the structure with the factor of safety, but I am not applying any factor of safety to the soil. So that is why Q safe is calculated like this and not calculated like QU divided by factor of safety, because if I write like this, it is having the meaning that I have applied a factor of safety to the pressure exerted by the soil, which is entirely wrong. So this is the right way of calculating the factor of safety to the structural components only, and this is the right way of approaching net safe bearing capacity. I'm sorry, gross safe bearing capacity, or simply the safe bearing capacity. All this time we were talking about the effect of shear failure criteria only, but in the beginning itself we have seen that there are two important criteria that you should keep in mind when you are designing a shallow foundation or any foundation in that matter. One is shear failure criteria and the other one is settlement criteria. This is where the safe bearing pressure comes into picture, which is dealing with the settlement criteria. That is maximum net intensity of loading. That is the additional loading from the structure on the foundation that can be allowed on the soil without the settlement exceeding the permissible value. You will see all the permissible values in the upcoming lectures. But for now, understand that the safe bearing pressure is dealing with the settlement criteria. For the criteria related to shear, you might have seen ultimate, net ultimate, safe and net safe bearing capacities, whereas the safe bearing pressure is dealing with the settlement criteria. Remember that there is no factor of safety involved in determining the safe bearing pressure. So you may wonder which one I should choose then. I have one criteria called shear failure criteria and one criteria called settlement criteria. Which one I should consider for my design? Well, from shear failure criteria, you might have calculated your net safe bearing capacity. as, for example, some 250 kilonewton per meter square. Whereas from settlement criteria, it is net safe bearing pressure is going to be 200 kilonewton per meter square. While for the design, the allowable bearing pressure is always the smallest value of whatever you have got from the shear failure criteria and settlement criteria. See here, although the net safe bearing capacity is 250 kilonewton per meter square, from settlement criteria it is saying that the structure will fail once it reaches 200 kilonewton per meter square, which means you should do all the further design having your allowable bearing pressure as 200 kilonewton per meter square. So QA net is equal to least of net safe bearing capacity from shear criteria and safe bearing pressure from settlement criteria. You should always choose the least value of shear failure and settlement criteria. Maybe sometimes shear failure criteria will be having a lesser value when compared to settlement criteria. Anything is possible, but keep it in mind that you should always choose the lower value. Let's have a quick recap of what we have seen so far. Remember that if you are talking about gross, then it means you are talking about the effect of structure plus soil plus foundation. This I am talking in terms of load. If you are talking in terms of net or simply Qn, it is the effect of structure plus Q of foundation. You are not talking about the soil here. This same idea is applicable for pressure also, where in general Q ultimate or Q gross ultimate is nothing but gross load divided by the area, where the area is length into breadth. Now we are going to see about the terminologies. First is gross ultimate or simply ultimate bearing capacity. It's nothing but QU. It is the maximum gross intensity of loading that the soil can bear without having the effect of shear failure. So this is nothing but gross load divided by cross sectional area. The next one is net ultimate bearing capacity, which is QNU. As I have told you, this is nothing but ultimate bearing capacity minus the effect of soil pressure. Next is net safe bearing capacity. Here I have the term called safe, which means I should apply a factor of safety to my load. But still it is net, which means I have not included the effect of soil. This is QNU divided by factor of safety, which is nothing but QU minus gamma DF divided by factor of safety. Finally, safe bearing capacity, which means the gross term is there. Usually they won't say it as gross safe bearing capacity, just as safe bearing capacity. Gross safe bearing capacity. QS is nothing but QNS plus gamma DF, which is QNU divided by factor of safety plus gamma DF. All these things belongs to shear criteria. What is settlement criteria? We should ensure the net load on the soil, if applied, the soil should not exceed the permissible settlement value of its particular type. So QNP is safe bearing pressure. It's safe bearing pressure. This is settlement criteria. Then what is this allowable bearing pressure? The one which you will be using for design. QA net is nothing but least of QNS and QNP. That is the least value of shear criteria and settlement criteria. In the next video, let us discuss about the various types of shear failure. Thank you.